Okay, sharing my screen. Okay. Can you see my screen? It's visible, right? Okay, we'll get started. So today we'll talk about three topics. One is tokenization, stopwords, lemmatization, and stemming related to NLP. So what are they? How are they useful in case of NLP problems? So previously we learned Python, we learned about pandas and all that. Then last session we had regular expressions topic. So how to use regular expressions to instead of using fancy machine learning or deep learning algorithms. Some of the use cases or some of the problems can just be solved just using regular expressions. And even in NLP, in some of the cases, while you're doing modeling, right, like data cleaning or data pre-processing, in that area also regular expressions were used. So we covered all that basics and stuff. So the next one we'll talk about tokenization, stopwords, stemming, and lemmatization. Then the next session also we'll talk about parts of speech tagging and all that. Okay, we get started with tokenization. So what is tokenization? So you know that natural language processing, the input is always text, right? And you will get that text from various sources. So you might get it like if a company wants tweet sentiment analysis. So you need to go to that Twitter handle of that company and you have to use some web scraping tools and you have to get that all the tweets related to that company or a product, how people are reacting to that product. And you have to use sentiment analysis and figure it out whether the reviews were positive or negative, like how much percent are positive reviews and how much percent are negative reviews. So that company will know if they released a new product, they can know uh, the sentiment of the people, whether that product is doing good in the market or it is doing little bit bad. If it is doing little bit bad, if the reviews are bad, then they will look into those and try to resolve the issues that people are facing, and they will again may relaunch the product. So in this case, you are using Twitter data. So Twitter data usually contains a lot of messy things, not only text, but you will have any links or you will have any emojis and lot of stuff, right? And also sometimes you also need to read it in a website. You may need to scrap the data from a website and you need to read it, or you need to read the data in maybe some documents that may also like messy or Facebook comments or so data you it will be in many forms. You may need to read it in many other sources. And you won't get a clean data. Usually data will be messy. It contains HTML tags, it contains some emojis, or it contains some unnecessary text, which is not like English. Some garbage text will be there. So you should not pass that text to the models. Before passing text to the models, you have to make sure the text is clean. What do we mean by text is clean is that you have to actually remove all those HTML tags or garbage text, or maybe convert those emojis into different format, or just remove those emojis. So when you are passing data to the model, you have to make sure the data is clean. So these are the steps that usually part of a cleaning process. So tokenization, stopwords, stemming, and lemmatization may not be only for pre-processing. Also, to there are some other use cases of it that I will explain it going forward. So the first one is tokenization. So what do we mean by tokenization? So usually tokenization helps to convert paragraphs into sentences and words, and converted words will be in a form of list. So if you take an example of, let's say there is a sentence called "It is raining," right? So what happens if you apply tokenizations on top of it? Let's say you want to divide this text based on spaces, then it will divide into "it is" and "raining." So different words based on space. Since we have two spaces here, so the text got divided into three words. The sentence got divided into three words. Correct. So this is one way that you can divide the sentence into words Or also you can divide if you have a huge amount of document data, as a paragraph kind of stuff. You can use tokenization methods to divide those paragraph into sentence first, and then divide the sentence into words. So that is another way that you can use tokenization. So there are different libraries out there to do tokenization like NLTK, GenSim, Keras, etc. Uh, and tokenization can also be done using separate words or sentences. The text is split into words using a separation technique called as word tokenization, and same separation can be done for sentences that I just talked about. So there are various tokenization techniques available which are applicable based on language and purpose of modeling. Below are few tokenization techniques used in NLP. So there are multiple tokenization algorithms or ways to tokenize the text. So we'll go through one by one. So the first one is white space tokenization that I talked about. Yeah. Sorry, what? Zoom it. Okay, okay. Yeah, yeah. 1 second, I will do it. Yes. Is it fine now? Just give me 1 minute. I will be back. Okay. Let me check if recording is happening. Okay. Yeah. So the first one is white space tokenization. So what do we mean by white space tokenization is that you will just divide the sentence based on spaces. So let's say the sentence is like I love NLP because it is interesting. So using white space tokenization, what happens is that you will just divide this sentence into words based on the spaces between them. So here we have space after I, after love, after NLP, after because, after it, and after is. So it will divide into I love NLP because it is interesting. So divide that sentence into multiple words and you will get the output in a form of a list. So this is now how we do it if you go with the white space tokenization. So it works good in case of English, but if you can't apply the same technique if you're working with other languages like Urdu, Japanese, Hindi, because in English maybe dividing every word may contain a different meaning and it makes sense to divide it based on a space. But if you look at other techniques, right, like other languages like Urdu, Hindi, and all that, so that might not be the case. So you may not divide data in form of spaces. Maybe you may have a different spaces in between, but that may not give you a good context if you are using other languages. For only English, it makes sense to divide the data in form of a white space. So that is the one major disadvantage of using white space tokenization. You can only use it for English, but not for other languages like Urdu, Japanese, Hindi. Because in Urdu or Hindi, maybe like even though there is a space, maybe this whole text maybe one one it gives you one meaning. So you can't use it for different languages. Mostly works well for English. And the next one is like dictionary based tokenization. So basically you will have a dictionary of words, right? Then you will look into that dictionary and you will see whether that word is matching. Then if the word is matching, then you will divide that. If that word is not matching, you will have some rules, special rules on if the word is not matching, how do you divide it? So let's say I have a dictionary that has I love NLP because, and I have interesting. So I have these words in dictionary, but I don't have it is. So I will go through one by one word. I will see whether this word is there. I is there in the dictionary. Okay, fine. Love is there. Yes. NLP is there. Yes. Because is there. Yes. Interesting is there. Yes. So we'll divide based on that. But it and is not there. So you will come up with some different rules on how to how to divide this. Right. It and is. We will going forward. We'll look at how that happens. So this is one type of a dictionary based tokenization. So tokens will be already existing in the dictionary. If the token is not found, you will apply some special rules to tokenize it. And the next one is like rule based tokenization. So instead of just dividing it in a form of spaces, right? You might want to divide it based on some of the rules that you might think that is important. So maybe you might say, wherever you found colon or something, divide only based on that. Or whenever you found a question mark or something like that, then just divide only at that point, not on spaces. So in rule based tokenizations, based on your problem that you are solving, that you think that I have to divide this text not on spaces but on different rules. Maybe I don't want to divide it based on space. I want to divide it by comma, or I want to divide it by question mark. So it depends upon what is the problem that you are solving, and if you know that specific rules that make sense to tokenize the text, then you can add those rules as part of tokenization, and you can do that. Okay. So one question that I have for anyone can answer is like, if I want to do it as part of space, right? If we given a text, I want to divide this text sentence into words by using space. What is the method that you use in Python? Because you already learned Python, right? Any idea? No, no, space. I'm not talking about space, not new line. So I have a text here and I want to divide it based on space into words. Yeah, so I have to use sentence dot split. By default it will divide based on space, but if you want to divide it based on comma, you can just give in that function comma, so that divide based on comma. So split function is, you can use split function to do the tokenization like this. Okay, so another way of doing tokenization is regular expression tokenization. So instead of giving some, it also a part of rules, rule-based tokenization, right? So you are using some rules to divide the data. So you can say like regular expression tokenizer, you can import it from NLTK, and you will give some regular expression that you think is necessary for your specific problem that you are solving, and based on that, you will divide the text by giving some regular expressions. So that is another way of doing it. So there is another way of doing tokenization, something called as pen tree bank. So this tokenizer incorporates very common rules of English word tokenization. It separate phrase terminating punctuations like question mark, no explanatory dot, comma, or colon. So instead of the problem with using space tokenization is that, let's say after interesting you had a colon. So basically, in actual scenario, you want to divide it in a such a way that you want words to be separate and symbols to be separate. You don't want symbols and words to be in one word, because sometimes after interesting there might be colon. After some time, maybe in another use case, after interesting there might be like question mark or comma, something like that. The idea is, so why are we using this tokenization is that if you take one small use case, so let's say I want to identify, given a review, Amazon review, I want to say whether this is a positive review or a negative review. So one simple way to no, identify that is that you will just go through all the positive reviews that you have previously, and you will see what are the commonly occurring words. So you will take all the sentences, you divide those into words, and you will count what are the commonly occurring words in positive reviews. So if you look at it, usually what words you will see like, okay, this good or nice, or the words that actually positive, you will find those words like good, very, awesome, something like that. So the count of those words will be high in if you take in case of positive reviews. If you take on negative reviews, you will see words like bad, worst, something like that. So by just counting these words, right, so if given a new text, you will just count like you will just see how many times that word is there in the positive review, or how many times it word is there in the negative review. So let's say I've given a new sentence of the review saying that this product is very good. So I will just look at how many times this occurred in positive review, or how many times this occurred in the negative review, and I will go through word by word. I found that very and good is occurring mostly in the positive review, right? More number of times it occurred in the positive review, so I can directly say it's a positive review, right? So that's how tokenization helps. You divide the sentences into words, and then you will count how many times that word occurred in that particular reviews and all that. So that use case that is there. But the problem here is, let's say you said this product is very good, but after good you gave colon, but in the reviews that you have counted that you had in your hand, there is no colon after good. Then what happens? There will be no matching happening, right? So the program will consider both as a different words, just because there is a colon after good. But in original scenario, you want both to be same. So that's how, where if you use just space tokenization, it fails in those cases. So ideally, what you want to divide the sentence into words, and if there are any symbols along with the words, you want them to divide it as a separate uh, no word itself. Like if you, that's where this pen tree bank comes into picture. So it separates phased terminating punctuations. Like if there is any question mark, colon or exclamation mark, automatically it divides that. It divides that into a separate word kind of stuff. And if there are any numbers also, it divides separately. And along with it, like if you have something like don't, right? Instead of dividing it as don't, it divide into do and nt. So these are different techniques they are already implemented in the background. So if this is the word that they have given, what you don't want to be done to yourself, don't do to others. So if you use tree bank word tokenizer, it will divide like what you, instead of don't, just dividing it as don't, it will divide as do and nt. And want to be done to yourself, and again space, comma is there, right? There is a comma. Instead of having it yourself comma as one word, it divided yourself into one and comma as one, right? Two others, and also divided these three colons into separate one instead of attaching it to the words. So that is the useful of using this pen tree bank. Instead of just blindly instead of dividing it using space, it will it adds some rules in between that make sense, like dividing if there are any words like don't, won't, or if you have a shortcuts written, it will divide that into meaningful like do and nt as a separate things. And if there are any any symbols like colon, a question mark or something like that, it will consider it as a separate token. It will divide into a separate token instead of attaching it to the word. So that is the use of pen tree bank tokenizer. And the next one is about a tweet tokenizer. So it's specifically designed for tweets. If you do any, web scraping on tweets, so tweets will have a separate different kind of format. Usually people will apply emojis and stuff, right? So you basically want those emojis and stuff to be a different tokens. So if you are using Twitter data, it was recommended to use tweet tokenizer. So internally they have not done some rules, because they know like tweet specifically contains some emojis or some links or something like that. So based on that, they have written some rules on it. So if you are trying to use a Twitter kind of data, so it was recommended to use tweet tokenizer. So you can see here there are two no emoji kind of symbols, and it were divided into separate tokens instead of one. Sometimes maybe if you use just others, maybe it may not be the case. Sometimes they may not, they might actually ignore these emojis also. If you use like a dictionary kind of tokenizer, because this won't be present in the dictionary, so it will neglect it, right? So that's the use of tweet tokenizer. And there is one more tokenizer called as MWT tokenizer. So the idea of this is that sometimes you might get in English, you might get two words separately, but actually they represent one meaning. So let's say Hunger Games. So here hunger and games are not like two different meanings, right? So hunger and games are actually one, represent one meaning, but just that they're divided into two words based on space. It doesn't mean that they are different. So if you know, like you want those kind of words to be combined into one category, then you just use MW tokenizer, and you will just say tokenizer dot add underscore MWB, and you will give whatever you want two words to be combined as one. So in this case, like hunger and games, instead of dividing hunger and games as two different words, you are actually combining those words into one, because those actually mean one meaning. So you can see then it will just combine hunger and games as one entity instead of hunger and games differently. Okay, so that is the thing about MWT tokenizer, and the next one is about Spacey tokenizer. So Spacey tokenizer, I think it also, whatever we talked before, it uses both space and also uses punctuation tokenization that we talked about. Like based on punctuation, it divide the words and punctuations differently, and also it has rule-based tokenizations. So if you want to use any rule-based, you can just import in Spacey, and you can give your rules whatever you want using those methods, and you can incorporate those rules while you are doing tokenization. Okay, so this is if you don't you love transformers or I mean sorry, there should be NLP, so we should do. So it will divide into don't you love this emoji symbol, just that. Okay, sorry, here the instead of transformer here this should be NLP. So NLP question mark we should do and dot. Okay, that's the use of white space tokenizer. Any doubts as of now? Anything that you want me to repeat? This seems to be fine, right? Yeah. So there are disadvantages of all the above methods. The main, if you look at the disadvantages, right? So while it's most intuitive way to split text into smaller chunks, this tokenization method can lead to problems of massive text corpora. So in case of space punctuation tokenization, usually generate a very big vocabulary. So Transformer Excel, which used like space punctuation tokenization, had a vocabulary of 2,67,735 vocabulary size, which is very huge, right? So this is the main disadvantage of using about tokenizers. It actually increase your vocabulary size. So when you are training the model, when you are loading the data, it usually consumes a lot of memory and your training would be slow and there are a lot of issues that you need to face if your vocabulary size is huge. So that is one of the major disadvantage. So it increases the memory where you need to store and also the time complexity, right? So you can say, okay, why, if that is the case, like if you think memory is the constraint, why can't we just instead of using space and punctuation tokenization, why can't we just use a simple character tokenization? So let's say if you just have don't you love transformers, we should do instead of dividing it into the spaces, I will just divide it into characters. So I will say D as one, O as one, N as one, T as one, Y as one, O as one, zero, U as one, and something like that. So if you take just characters, there will be all like 200 characters. By just having 200 characters, you are representing the vocabulary. So why can't I just choose character based tokenization if memory is the constraint? The problem with that is, yes, true. If you use character-based tokenization, the memory size will reduce. The vocabulary size comes down to just 200. But the problem is that you are actually losing information, context information. So if you look at words, it will give you some meaning. But if you just look at characters, it won't give you any meaning, right? So that's the main problem. By using characterized tokenization, the problem is that you are losing the context information. It's true that you are reducing the vocabulary size and all that, and the memory is also getting reduced, but only problem with that approach is that it's not a meaningful way, or it doesn't give you any context if you divide it just based on characters. So at the end of the day, so you want in a middle ground, so you don't want too much vocabulary size, you want to reduce the vocabulary size, and also you want meaningful context while you are dividing the data, sentences into some tokens. So the middle way, people came up with something called as subword tokenization. So by using subword tokenization methods, usually the vocabulary size will be around 50,000, but not greater than that. So instead of having 2,67,000, it was reduced to 50,000. And also it gives you good meaning, right? So they've found a middle ground. So they are not using too much vocabulary size like 2,67,000. They are also not using very less like 200 or something like that, and they don't want to lose the context. So they found a middle ground, which they something called as they came up with subword tokenization, where the vocabulary size will be around 50,000, but you are also preserving the context. So let's see how it is done. So this tokenization is very useful for specific applications where subwords make significance. In these techniques, the most frequently used words are given unique IDs and less frequent words are splits into subwords, and they best represent the meaning independently. So for example, if a word few is appearing frequently in the text, it will be assigned a unique ID, where fewer and fewest, which are rare words and less frequent in the text, will be splitted into subwords like few, ER, and EST. This helps the language model not to learn fewer and fewest as two separate words. This allows to identify the unknown words in a dataset during training. There are different types of subword tokenization given below by byte encoding and WordPress. So the idea is subword tokenization is that to reduce the vocabulary size, the logic that they came up with, they look at the whole, they train, usually they have like Wikipedia data on all that, So they crawl over the data and they will see what are the words that are frequently occurring across the whole Wikipedia, right? Then they got that words that are frequently occurring. They store it in a form of dictionary. Then what they will do, then if a new word comes into the picture, they will see whether that word is directly there in the dictionary. Let's say unfriendly is there. They will look whether this unfriendly is there as part of their vocabulary. So they determine that okay, I just want only 50,000 words as a vocabulary size. Then they collected those 50,000 words based on the words that are occurring very frequently. They captured that and they had a cutoff of 50,000. So they fixed the vocabulary size. Now a new word comes, unfriendly. Now they will see whether this unfriendly word is there in the vocabulary, in the dictionary. In this case, unfriendly word is not there. Then what they will do, instead of adding this into vocabulary, they divide this word into subwords. So first they divide it into half. So let's say they divide into UNFRI and ENDLY. So they will look if UNFRI is there or ENDLY is there. Let's say those were not present. So they again divided into subwords. So they will divide into subwords until they find those subwords in the vocabulary. So in this case, at the end, they divided this unfriendly into three subwords like un, friend, and ly. In this case, they were able to find okay, UN is there, so they will assign an ID to UN based on the no dictionary ID it has. They are also able to find friend in the dictionary, so they assign an ID to friend, and they are also able to identify ly in the dictionary. So they will just assign an ID that was there in the dictionary for ly. So this is how they are doing it. So the subword tokenization algorithm says that you fix a vocabulary size. Let's say you fix it to 50,000. Then you will go through whole Wikipedia or whatever data you have. You collect the words that are occurring very frequently. Then you will store it as part of a dictionary or stuff. Then if a new word comes, if you want to assign it a ID, right? If you want to divide it, then you will see whether that word is there in the dictionary. If it is there, you will just assign that ID to that word. If that word is not there, you will divide that word into multiple subwords and you will see if that subword is there in the dictionary. If that subword is there, then you will assign that ID. So that is how subword tokenization works. So for subword tokenization, they have two different kinds like word piece tokenization and something called as byte level byte pair encoding. So first I will cover something called as byte pair encoding. So byte pair encoding says that first you have to extract the words from a given data set along with their count. So that I mentioned, right? You will go through the data and you will see how many times a particular word is occurring and you'll collect that. You will have the count of it. So let's say I have some sentences, then I found out that cost word is occurring two times, best word is occurring two times, menu is occurring one time, men is occurring one time, and camel is occurring one time. I will first collect this count for every word, how many times it was occurring in the given data. Then you will define a vocabulary size. Then I will say, okay, I just want like 10 or 12 size. The vocabulary size should be just 10 or 12 words. Then you will split the words into character sequence. So whatever characters were there here, I will just split that words into character sequence. So up to that, I will get like A, B, C, E, L, M, N, O, S, T, U. So by this time, I got all the unique characters that were there in the data. Then I will go with add all the unique characters vocabulary, then select and merge the symbol pair that has highest frequency. Then going forward, you will see what are the two character words that are mostly occurring. If you look at it, ST is most occurring two character word because the count is 2 2, right? So basically it's occurring four times in the corpus. So we'll just add ST. Then you will see what is the next one. Then ME is occurring most number of times, like three times, I guess. So we'll add ME. Then you will see what is the next most occurring word. I think MEN. It occurred two times. So MEN, your vocabulary size got filled. You will stop it. So this is just an example. But basically, what happens in the real world is that like you will have a huge amount of Wikipedia data, which has like some millions of words and stuff. Then you will count all that and you will create a vocabulary size. You will say that okay, my vocabulary size is 50,000. Then based on that, you will do this algorithm. So you will divide first into characters. You will store all the unique characters. Then you will go through combination like when the first character is in, you will go to two character words, three character words, something like that. You see what is the highest frequency of words that are occurring. Then you will just add it in the vocabulary until you reach that vocabulary size, like 50,000. Then you will stop. Then if a new word comes into picture, so let's say I got a new word MEAN, then what I will do, I will divide this, I will see if mean is there in the vocabulary. So I don't have MEAN here. So what I will do, I will divide this word into subwords like ME and AN. Then I will see whether ME is there or AN is there. So ME is there, I am good. I will assign the ID to it. Then AN, I will see whether AN is there. So AN is not there. So again, I will divide that AN into A comma N. Then I will see whether A is there or N is there. So A is there and N is also there. So I'm good. So for this, you will have a unique ID. So A will have 10 ID, B will have 1 ID, C will have 3 as an ID, E will have 4 as an ID, something like that. So I'll just assign that IDs to it, right? So that is about byte pair encoding. Now there is something called as byte level byte pair encoding. So instead of the idea is instead of using characters, why can't we use byte level? So byte level is that you will divide the word into characters and you will take that character ASCII value and you will store it instead of just storing the characters. You are actually converting that characters again into some ASCII value and you're looking at showing that byte level information instead of character level information. So the advantage of doing is that it actually helps to use it across multiple languages, because at the end of the day, whatever language you use in computer, you have to convert it into byte level stuff, right? So it makes sense. Even if you use multi-level, multiple languages, anyhow, at the end of the day, you have to convert everything to byte level. So it will be you can share that vocabulary across the multiple languages, because at the end of the day, you're converting everything to byte level. Whatever language it may be, at the end of the day, you have to convert into byte level so that it's easy for you to match it. So that's we call as byte level byte pair encoding. So this is important because the most algorithms like BERT and Robota, basically BERT uses something called as word piece. So this word piece is nothing but very similar to byte pair encoding, just that they have this formula to count instead of manually counting like how many times a word occur. They are saying frequency of x comma y divided by frequency of x into frequency of y. So instead of saying st, instead of looking at how many times st occurred, they are dividing st into again subwords. So you will see how many times st is occurring divided by how many times s is occurring into how many times y is occurring. Something like that. So they have this kind of formula instead of manually calculating how many times no that st would occur. They're having this formula of frequency, just similar to byte pair encoding. So BUT usually uses word pair tokenization, and Robota uses byte level byte pair encoding. So there is that difference. So this is so that's why I'm stressing much on this. So this is very important to understand, because there might be questions like usually everyone asks is like what's the difference between BERT and Robota. So the first difference is that BERT uses word piece tokenizer and Robota uses byte level byte pair encoding. Yeah, 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 yeah. So context in the sense you are actually storing the word itself only, right? At the end of the day. So the idea is you will just assign IDs, but you are actually storing the whole word. I didn't get you. What is the key here? Yeah. Yeah, so actually we'll give a unique value, unique ID to everyone here. Like all the whatever the vocabulary you have, you will have a unique ID. Then you will look at. So let's say if mean is there, I will just say mean is there or not. If the mean word is there, let's say the mean had like 20th ID that was assigned to it. So I will just add 20. So if the mean is not there, I will divide it into ME and AN. Then I will see ME is there. ME is there, let's say at the sixth token, sorry, sixth ID. Then I will add as 6 and an is there. I will check for an is not there, then I will divide into an into again a and n. Then I will look at a is there, so I will assign 0 to a and I will assign n like some like say 4 or fifth one, fifth id. So the model will assign in such a way that the model will know these are actually one only. The model will don't treat it as a separate characters again. So don't confuse like, okay, I'm divided into characters, so by said it like dividing into character doesn't make sense. It doesn't have context representation, right? But here we will tell the model that even though I divided into characters just to match it with the vocabulary, this is actually same, this is one only. So that's how we are actually reducing the vocabulary size, right? And also maintaining the context information. Let's say if I don't maintain vocabulary size, what happens again? I have to add this an as a separate vocabulary, separate id again. So that will increase, right? That will increase the vocabulary size again. So instead of that, you will fix the vocabulary size, and based on that you will just see whether there is a match. If there is no match, you will divide into sub words and up to characters. Then if there is then anyhow at the end of the day, if you divide into characters, there will be a match. But instead of giving a instead of saying a model that okay, consider me as a separate, a as a separate, n as a separate, you actually tell the model that hey, these three are same only, just that I assigned some ids, but just these three are same. Don't consider them as a separate stuff. So basically, they will give something called as hashes. If you divide a word into subwords, right? So they will give as ME as the first one. For AN, they will give two hashes before it. If you divide again AN into A comma N, again before A you will have two hashes, and again before N you will have two hashes. So that the model will know whatever a word is there, and if it's seeing hashes after that, it will contains everything as one until and unless there is no hash again. Yeah. So that's about the subword tokenization stuff. Any doubts? Anyone have any other doubts? No, vocabulary size is fixed 50,000. I mean, usually they will use Wikipedia data or huge amount of data, right? From that, they fixed it as like 50,000 vocabulary size. I mean, just saying it an example based on the algorithm. They usually have some random size based on what they think is good. It changes for algorithm to algorithm. So I think for Bert it was less, but for Robot I think it was higher, or vice versa, but it won't be same. Depend upon the algorithm, it will change. Yeah, so that's about tokenization. So I just given some code in the below, so you can just go through it whenever you get some time. It's just like self-explanatory. You don't, I don't need to explain. I guess just need to import some libraries and just pass the sentences and all that. If you don't understand anything, just let me know. I will help you out, or we will write like more clean code for you to get it understand. Okay, so this is about tokenization. And now let's move to stopwords. Yeah. So what are stop words? So the words which are filtered out before processing the data is called stop words. These are most common words in any language, like pronouns, prepositions, conjunctions, etc. that add very little information to the text. So examples are like a, and, are, is, at, be, by, for. So these we call these type of words as stop words. So why do we call this as stop words? Is that usually they don't give you any meaningful information. So let's say if you take an example of the same thing like Amazon find food reviews. So you will be using these type of words a lot, both in positive review and negative review, right? So it won't actually give you any context, any information. So I can use like, okay, this product is very good. So is occurring in a positive review. I'm also saying this product is very bad. So is also occurring in the negative review. So this doesn't give you any actual information, right? So in that case, what you will say, you will, there is words that are already predefined as stop words. So you will remove those stop words from your data, right? So and you will use remaining text for the model. You will remove the stop words and you will use the remaining text for the model. So by this, you are, there will be some advantages. So first one is you're reducing the data set size. So you are removing unnecessary words that you think are not necessary. So that training time will also get reduced and tokens will also be very less. So that is one advantage. But just remember, it's not a case that you will remove stop words for every problem. So depend upon the problem that you are solving. Maybe sometimes these stop words might be important, right? So you have to be a little bit careful on understand the context on where what is the problem that you are working on, and see whether these stop words are necessary for you or not necessary. So in case of reviews, right, Amazon reviews, those may not be necessary. So you can directly go ahead and remove it. But there may be one scenario where usually you can actually divide a sentence into two classes. So let's say, I will tell you an example. Like, let's say we will write requirements, right? Before for any project. So there will be two types of requirements, like critical requirements or non-critical requirements. So maybe for critical requirements, you will have some words like not, should be, or is, or something. Maybe not, or which you think as a stop word may be important over there. Maybe in. So let's say I have a requirement that says this value should be always within the range, right? And I will give the range. In is actually important here because only for critical requirements I will use a word in, but for non-critical information I may not be using in mostly, right? Or I can have a word like not, right? Maybe I will use not very specifically only for uh, critical requirements. I may not be using not for non-critical requirements, right? So you have to just look at it based on the problem that you're solving and stuff. You have to see whether stop removing stop words makes no sense for you, or having stop words as part of data makes sense for you. So just have a caution over there. Just don't blindly remove stop words. Understand the problem that you are solving. See whether stop words make sense for you. If you think that stop words is actually a good future to divide a particular class, then you have to consider stop words. You should not remove it. If you think stop words is not necessary, then you can remove those as part of your text and you can process the remaining text. So that's about stop words. So the next one is about stemming and lemmatization. So what is stemming and what is lemmatization? So what stemming says is that stemming in literally terms is the process of cutting down the branches of a tree to its stem. So effectively with the use of some basic rules, any token can be cut down to its stem, base form. Stemming is more of a crude rule-based process by which we want to club together different variations of the token. So let's say I have a word eat. Usually, word eat, people use it in different variations. So some might be saying, I'm eating this mango. Some might saying that I have eaten this mango. Or some might be saying, I usually eats this mango, right? And so on. But at the end of the day, this all refers to eat. Even though the spelling is different, at the end of the day, everything related to eat. it gives the sense that is that they're actually eating. It's kind of a meaning that they have eaten. Everything comes at the end of the day to eat only. Whether it's eating, eaten, or eats, you have comes under the end of the day to eat, right? So what stemming says that if there is something like this, eaten, eats, eat, you will cut the stemming. Stem in the sense the last thing you will have like ing, en, es, something like that. You will cut that end of those strings and you will convert that into root word, right? So that's what it the stemming says. So if you look at this example, I prefer not to argue. So I is, I think, maybe a root word. Prefer is also a root word. Not is a root word. To is a root word. But argue, I can convert that argue into argu. Argu. I'm actually removing this e and converting into argu. So what we are saying is that we are interested in stripping the suffix at the end of the word. When stemming, we are interested in reduce the inflected or derived word to its base form. Take a look at the figure where the stems and affixes called as morphemes are extracted and used to reduce inflections to the base form. For instance, the word cats has two morphemes like cat and s. The cat being the stem and s being the affix. So what we basically do, we remove that affix and we only keep the stem. So stemming is mostly commonly used by search engines for indexing words. Instead of storing all forms of words, a search engine can store only the stems, greatly reducing the size of index while increasing the retrieval accuracy. Right. So basically, what we are trying to say is, people might even if you take again Amazon reviews example. So let someone says I have eaten this mango. This is good. Someone would have said sorry, I'm eating this mango, this is good. Someone would have said, I have eaten this mango, this is good. Someone would have said, I usually eats mango and this is good. So basically these are good positive reviews, right? Not negative reviews. But let's say what we are trying to do in the basic case, we are just counting how many times a word occur, right? But if you look at it, there is no match here. So eating is not matching with eaten, eaten is not matching with eats. So if you don't convert into stem word, you usually refer these three words as a three different words. So the idea is instead of considering three words as a three different words, because these three words at the end of the day refers to the same meaning, convert that into the its stem word, which is nothing but let's say eat. Then you can just say okay, three times it occurred. Okay, then it's a positive review. So now you can count. So at the end of the day, if I convert eating to eat, eaten to eat, and eat, so everything is matching to it. So I will say, okay, this is positive review. So that's what the meaning of stemming. You might be referring a particular word in different ways, like eating, eaten, eats. At the end of the day, they all refers to one word, eat, with the same meaning. So you instead of counting them as a different tokens or different meaning, you want to now combine saying you want to say that those all belongs to one token, which is it. So that's where you use stemming. You'll just stem the suffixes that they have mentioned it, right? Wherever you suffix, you will remove those and convert it to the stem word. So you have multiple algorithms to do this, like Porter stemmer, Lancaster stemmer, regular expression stemmer, and snowball stemmer. So a rule-based stemmer like removing yes, yes, or ing or ed can give you a precision of more than 70%, while Porter stemmer also uses more rules and can achieve very good accuracies. So if you want to implement a stemmer method, right, how do you implement it? You will just see if there are any, characters that were occurring at the end of the word, like yes or es or ing, ed. You want to cut those, and you want to save the remaining word, right? So that's where it's a basic rule that you can apply as a part of stemming method. But Porter stemmer, they also add some other logics into it. So basically people uses Porter stemmer. So you can just say import Porter stemmer, and you can just say pass it any word like psd.stem shopping. It converts that into shop. So basically removing this ping at the end. So if I say I prefer not to argue, So it just removed the E at the end and converted to ARG, right? So this is the one. And however, there are many stemming algorithms around, and the precision and performance of them differ. You might want to have a look at here for more details. And I have used a Porter stemmer most often, and if you work with English, it's good enough. There is a family of snowball stemmers that can be used for different languages. For Hindi also, there is a different stemmer. So this is the example of snowball stemmer. So you can say import snowball stemmer English. You want to apply it to English. So I prefer not to argue. Again, this argue is divided into ARGU. Okay. So regular expression stemmer, just you will remove the ing and kind of stuff. Singular regular expressions and remove any prefix of it that matches the expression. So you can have your own expression kind of stuff, and you can use the regular expression stemmer to stem it. So cooking is divided into cook. Okay, and Lancaster stemmer, the functions of class are just like functions of Porter stemmer, but can produce slightly different results, is known as slightly more aggressive than Porter stemmer. So very similar to Porter stemmer, just maybe a little bit aggressive compared to Porter stemmer. Aggressive in the sense maybe it will be too strict while converting it to stem stem word for every word. Okay, so this is about stemming. So I thought you just understood the concept. So stemming is nothing but you might have different words occurring in different formats, but at the end of the day, they all refers to its stem word, which is in this case example eat. There may be a lot of other words, right? Like sleeping, sleeps. At the end of the day, it's sleep, right? Convey the same information. So you want to convert different words into its no stem word. So that's where you use stemming. You will remove like suffixes like es, ing, or something like that, and you will convert it to the stem word. So that's about stemming. Now we will go through lemmatization. So what is lemmatization? So lemmatization is more methodical way of converting all grammatical inflected forms of the root word. Lemmatization use context. So the problem with the stemming is that it won't use any context. It blindly, follow some rules, and it will, convert the word into its stem form. But lemmatization use the context and parts of speech to determine the inflected form of word, and applies different normalization rules of each part of speech to get the root word. So what lemmatization does is, instead of blindly, converting it to some stem word, it will convert it to the root word and uses some context and also parts of speech to determine what root word it has to convert. So for instance, a lemmatization process reduce the inflections am, are, and is to base form B. So if you encounter any am or is, it actually converts to base form B. So it's helpful for normalizing text for text classification tasks or search engines and variety of other NLP tasks such as sentiment classification. So mostly used for classification, may not be useful for like NER kind of examples, because sometimes you should not use lemmatization or stemming over there. We'll come to that afterwards. Why should not we use it? But sometimes these techniques works brilliantly well in case of classification task. If you want to identify positive review, negative review, spam or not spam kind of stuff, right? In classification kind of task, if you're dealing with the text, these methods are very helpful. So you can see if I say I love coding and writing, if I pass it to lemmatization, what it will does, it will convert I to pronoun, and it will convert love to love. Anyhow, it's in the root word, coding to code, and to and writing to write. So it actually convert the word to its root form, right? So that's how we all use them, as I mentioned, like previously also again. If you convert to the root word, you can actually it will be good for you. Basically you're saying whatever either it's a coding or writing, at the end of the day it refers to code or write. It's not a different word, or it's not a different meaning. So if you use any navy bias kind of algorithm, right? So what you do at there, you basically count the number of words that were there in a particular class, right? So if you have code and coding as a different word, you will consider them as a different words instead of considering them as one word. Basically they usually means the same thing, but you're just considering them as a different word. Instead of that, if you can convert that into a root word or a stem word, you can actually saying that both are same. So it will be useful for you when a new review comes or during the training process. It will help the model to understand that okay, these are all same, these are not different words, actually these are same words. Okay, so that's the use of lemmatization. And you so you can just say import spacey dot lemmatizer, and you can just load this algorithm encore WebSM, and you can just pass the sentence, and it will convert to the root word. I mean root words, allow coding to code and then writing to write. So these are the different changes. So if you use stemming for change kind of stuff, right? If you have words like change, changing, changes, changer, and changer, it will convert to chang. If you use lemmatization, it converts to root word, which is chang. The main difference between stemming and lemmatization is that stemming blindly follows some rules and convert to a word which is not actually a meaningful word. But lemmatization converts to root word, which has a meaning. So if you're dealing with any problem that you think, the meaning of the sentence is very important. You don't want to break the meaning of the sentence. It's not like just counting number of words, but you have to consider the meaning of the context of the sentence. So it's better to use lemmatization instead of stemming, because lemmatization preserves that meaning of the word, but stemming don't preserve the meaning of the word. It might be helpful mostly in cases if you want to count, but it doesn't help you if you are considering the context or meaning of the sentences, where you don't want to change, alter the meaning of the sentence. If you, in that case, you have to go for lemmatization. Okay, again, so same, had some differences here and stopwords. Yeah. So any questions on this? Stemming and lemmatization. Hello. If you think, if you don't want to change the meaning of the sentence, so if you look, you can see it, right? So at the end of the day, even if changing changes, it's converting to change, which is a meaningful word, right? But what is stemming doing? It's changing to some word called as chang. You don't have any meaning for this word chang, right? So that's the difference. So if you want if you're dealing with the task which you think the meaning of the sentence, you don't want to change it, then you go for lemmatization. But if you think meaning is not that important, I just want to count the words. By just counting the words, if you are able to get good accuracy, then go for stemming. Because the problem is stemming is very fast. You're not using any fancy algorithm in the background. But in the lemmatization, it's a little bit complex. You're looking at the context of the sentence. You're also looking at the POS, parts of speech and all that. Yeah, yeah. So no, not root word. Lemmatization changes to the root word. But stemming just removes that it has some rules. Okay, I will just remove ing, or I will just remove es, I will just remove ed. Usually that's what you occur, right? For every word, if you're at the end, you will just add ing, ed, es, or er. So what it does is it will just remove those, you will just look those kind of scenarios and will just remove it. It doesn't see at the end of the day what is it converting to. But lemmatization, it converts to the root word, like change. Okay.